We are done with questions for the Unity test tools, and now Sakari and Yan, Sakari is from Finland and Yan is from our Odessa office, will show you the magic of automated performance testing.
Yes, this is our topic. It's a long sentence, but what it actually means is that each version of Unity we release, we want to make it perform better than the previous ones. And that's what we are after. And I will start with showing you some performance, from some data that we get from our performance tests. So this is a table that shows performance test results for 3 versions of Unity. So one of them is 4.3, and then we have 2 versions, A1 and A2. These are 2 development versions of Unity. And what you can see in this table is that in version A1, we had a change in the iOS graphics code, and this change had an effect on Windows standalone performance. And this is something you may not necessarily notice easily if you have no feedback, because you are changing something on iOS somewhere on the other end of the code base, and you have an effect on Windows standalone performance. So when we have feedback, then we can notice this kind of bugs or performance regressions in the code. So what the table shows is we have 4 different graphics related tests, and then we have 3 versions of Unity where we have values from these performance tests. And the values here, what they are millisecond measurements from these tests. And you see that from 4.3 to A1, these values go up. And what it means for these tests, it means that the performance goes down. So it's performing worse than it was performing before. And then on the next version, A2, the value comes back to what it was in 4.3 or goes even lower than that. So then the performance comes back to a good level again. So using this data that we can get from our performance tests, we can notice this kind of bugs or performance regressions. And we can also notice when we have a fix that works for this kind of an issue. And one important point of how we do this kind of testing is that everything else needs to stay constant. The tests are the same, and also the hardware and the software that we use to run the tests, like the operating system, are the same. The only thing that changes is the version of Unity that we use. And then we can make sure that if we see a change in the data, that this is caused by some changes in the Unity. So this slide was to give an idea what we can get from performance tests and what is regression testing. And now I will show you at a kind of high level how we can get this kind of data, and how the automation system works to get this data. So at the top of this diagram we have our build automation system. From there we get versions of Unity, we get release versions of Unity, and then we get development versions of Unity. And then when we get these new versions, we save them to a local network disk. So if for some reason we would like to go back to older versions of Unity, we have them saved in a network disk. And then the next step is that we have performance test runners. Basically these are just can be just a PC or Mac, or then it's a device like Android. And this is the set of test runners that we currently have, and you know we have lots of different platforms. This is not yet covering all the platforms, but we keep adding new hardware and new platforms configuration all the time. So what we get out of these performance test runners is this performance data I just showed you, and we also get all the information related to where it was run and on what version it was run, and that data then ends up in a database. And from the database we can make the different reports, and then we can look for performance regressions. Okay, next slide. So that was kind of an overall view. Now we want to give you one example of a performance test that we have. So the example I will show you is meant to test this render texture functionality. Does someone know what a render texture is? Some people know. Okay, I can give a simplified idea. So you can use render textures, for example, like this: that you have a scene, and then you have a plane in your scene that you want to show something from another camera. So normally you have one camera that renders your scene, but sometimes you may want to have something on your scene that is rendered by another camera. So this then uses those render textures. Okay, let's switch to Unity. So next we will explain how this functionality is made into a performance test. Can we get the lights out? So what we do first when we want to test some functionality or performance test some functionality is we try to think of a scene that uses the functionality. And this is the scene that we came up with. And you can see it's nothing like the one I just showed you, because the purpose of this scene is a bit different. The idea here is that you want to make a scene that is using the functionality that you want to test, and using it in a way that most of the CPU time is spent on this functionality. And luckily, within Unity we have a tool that can help us determine if a scene is using the functionality that we want to test. And the tool is Profiler. I don't know if you have used Profiler, but I try to explain what we see here is that this test is rendered over 20 frames, and you can see the frames here. Something is happening here. And if you look at one of those frames over here, you will see that most of the CPU time is spent on doing the action that the test is doing. And then also you can see that within that thing, most of the time is spent on rendering, on camera rendering. So here we can see that we are actually using render textures, and we are spending time on rendering render textures. And the next thing is we want to make this scene into a Unity script that we can then run. And at this point I will let Jan continue explaining how this is.
Okay, so how we did all this magic. First, and probably the most successful decision was to not build another testing framework, but instead we decided to extend our existing runtime test framework. At the high level, runtime test can be explained as a small game deployed to device or run directly in editor, and you have capabilities to monitor execution and to ensure that everything runs as expected. So this we have a lot of runtime tests, and we run them on all platforms that we have. And as I said, instead of creating our own framework, we decided to work a little on runtime test and make performance test as a plugin for runtime test. We spent some time investing into this, and eventually we can create performance tests just by inheriting from runtime test. Then nested class should look familiar for those of you who are developing with Unity. It's usual C# script which inherits from mono behavior. The main distinction between performance tests and runtime tests that performance tests are not testing correctness. Because of that, they not contain any assertion. Instead, what they are doing, they are collecting data, samples. These samples could be frame time, total time, memory, or something else which we find interesting to collect. So in this case, we want to collect two measurements. We want to collect frame time, and we want to collect frame total time for whole test execution. To collect something, we create collectors. Very simple. So this is where all this magic happens. We ask our runtime test framework to provide us feature. Imagine this big piece of functionality which deploys to database, run on devices, collect all the samples information, and just a plugin to other framework. And we can have more such plugins. We do some initialization work, and then we instantiate all the small spheres with, which Sakari showed to you in previous slide. And we start one of the collectors, which will measure all the whole test execution time. Then we start a coroutine, which creates 20 render textures. And when coroutine yields, we will get into the update method. Update method is called per frame. So here we collect frame times. So we tell collector to record to no time, and if collector collected enough samples for this test, we decided that 20 samples is enough. We complete the test. As you can see, there are no assertions and no everything. And the way how it works, we can run it in different platforms, and one of them is editor, which is always available. So we are running, I should close Unity. Yeah, it's failed because we were having a Unity instance open. So if we run the test, it will instantiate all these small spheres, set up camera to render these spheres, and do all the things. So what it does, it prepares game project, deploy it to target platform, which could be anything which we support, and then we get test result. What we have in test result, we have platform. In this case, it's Windows editor. We have Unity version, and we often getting requests to compare performance of some feature between different versions of Unity, and we can easily do this by downloading appropriate version from our automation. And then we have some software, hardware and software information, and we have individual samples values, and we have medians. We rely on medians because in the most cases they describe the distribution in the best way. And also we have test version. So if we test, if we change the test, we in some cases we are not able to do comparison of this version of test with previous results. For instance, we found bug in test, it collected something incorrectly, and if we increase version of test, we will not compare it to these previous results anymore. So this is the way how it works. This test result, depending on your environment settings, is sent to console, or it could be sent to web service and further to database. And what we can obtain from it, Sakari will tell you more.
Well, actually, I was not planning to tell you anymore, but if you have any questions about all this,
I see that the status of the test is passed.
yes.
So what you can do for fail it? In other words, is there any ability to define some SLAs, service layer, SLA, service layer agreements, when you say that performance is too low and then it's pass? Or
Well, at the moment we are not doing it in the framework or in the test code. We do a kind of separate analysis of the data. So your question is about if this one is a failure compared to this one, and of course over here it's obvious because it's so much higher. But in some cases it may not be so obvious. So at the moment we don't have any, we don't define for each case any level. We look at the data at the moment individually and then decide based on some historical numbers we have. So at the moment it's more statistical, that we have lots of data from different versions, and if it suddenly goes up, we know that this seems to be a regression on the code.
In which units are you measuring performance? For
So,
example,
so
here.
these values, the tests are measuring all of these tests are measuring the rendering time of some set of frames, and the values are milliseconds of that time. So yeah, so it's 200 milliseconds. When it goes really bad, it takes 7 seconds to execute. Yes.
Can I write test on the C# or JavaScript and go to?
So these tests are all C#. Our test frameworks, the runtime tests, we
On the C#?
only C#. But this is an in-house tool, so at the moment it's not available for users yet.
and generally developing for Unity, so you can use C# or you can use some other languages. If you want to write a code, not using the studio, but write the
Yes,
code.
Unity scripts, you can
C#
do C# and JavaScript and
JavaScript.
what else do we have?
So yeah, but there's actually more to that story, because the scripts you're making. So when Dima and Sakari showed you a test in the example they gave you, you can basically see that what will be running when we are getting performance data is the regular Unity script. So we use these move behaviors that you can extend, and then you implement your own callbacks that will be executed. That's what drives your game. And those scripts are written in either C# or JavaScript or Google. We have those three. But then you can actually also write plugins yourselves. So it's possible that part of the game or the content you're making in Unity, maybe you want to do that in C or C++ or something else. You can actually do that, put it in a plugin, so put it in an assembly maybe, make it available for the editor, and then you can very, very easily call from C# into your own plugin, whatever it's written. Yes.
So you could actually implement these kind of tests in your as your own Unity scripts.
Any more questions? Nice.
Do you have some kind of analyzer to see which module actually influence the performance most, for example,
Yes.
for different tests?
Well, the idea of this regression testing is that we have the tests are aimed at a specific functionality. So if we have a test that is testing occlusion culling and the performance goes bad on that test, then we know that we have an issue with occlusion culling. In this case, the bug was related to more general rendering functionality, so it affected many different tests, but not all. It didn't affect all the tests. But for users, we have the profiler that will tell you that if you have a game and you have something not performing well, you can use the profiler to determine what is taking most of the CPU or GPU time or memory. Or is it right? Yes. So I kind of showed you quickly.
Some beautiful graphs.
Yes. First part.
This scene is created by scripts that I showed you. So, and eventually it created this Unity project, which we run in this case in Unity, but we can run it even on the phone.
We can maybe zoom in on the sphere a little bit or something, because you're not so visible. People might think it's a empty scene.
Well,
Or they
okay.
are disabled.
Well, this is not a good example seen anywhere because it's so simple. But the idea is that you have in the profiler you can see which part of your code is making most use of the CPU. Yeah, and then you can see the GPU usage. You can see rendering facts like how many protocols you have, how many files you have. You can see what is using your memory and audio, physics. 2D physics. So you get a lot of information from the profile.
Okay, but this tool is only for Unity, yes? Or it is,
So you mean how we analyze data, but
No,
sample
The
data?
profiler comes to Unity.
the profiler comes from Unity, and the regression test framework you saw is for our internal use, so it's not available to any Unity user.
Or do I visualize it? You mean like the data I showed you that do I make more visual representations of that? No, not really, no. At the moment, this level of this kind of way of looking at the data is pretty much
But actually, just to give you an idea about the speed at which we're doing things, as I mentioned, the first time I went to Odessa was 1.5 years ago. At that time, there was 2 guys on the team. So the team that we have now and what we have shown you tonight is basically all what we have done for most of the guys. It's less than a year. And many of these things are out there already. They're being used by our developers. They are being used in our sort of attempt to build quality into Unity 5 right from the beginning. So no, there are many things we are not doing yet, and that it would be very easy to do. We will contribute.
I can also say one thing. Imagine you're in your own software that you develop that one day you notice some part of it performs really badly all of a sudden. And try to figure out exactly what change caused that. It can be pretty painful and take a long time. In this case, we run this performance data on pretty close like releases. So we don't have a lot of changes in between them, and as soon as we notice anything performing badly, we can actually bisect in all the different changes, all the different commits that we have, and pinpoint the exact one that breaks it. Because we can measure performance on every commit. And that's maybe what's really, really powerful in this. It helps you pinpoint exactly, at least we can see which code changes created that regression.
Very often you don't need to debug very much because you can see immediately what broke it, who did it, and when was it done. That's typically good enough that you have an idea what happened.
So you received immediate response from the build server about performance testing?
Not yet. We are doing this. I mean, the most important thing for getting the performance test running, and it's complicated. Again, we have all these different configurations, and our automation is very much a layered architecture. So it's very hard to make top layers that are more stable than what's underneath, right? So if we have unstable platforms, it's hard to build stable automation on top of that. So we're taking it slowly. Right now we're doing performance tests on I guess all the standalone players on Android, selected platforms, the most stable ones that we have. And then we are running this every time we want to ship something. So before we send something out to our alpha beta users, customers, we are running this to them. And then we still find sometimes bugs, we still find workflow issues, and then we are fixing them. And then the idea is that as the tool gets more and more battle tested, more and more mature, more and more stable, we can also start basically running it more and more often and basically moving it upstream, so we, in the end, we'll have something like a continuous stream of data that immediately can tell us when something's wrong. We are not there yet, but we'll get there.
Cool. Do you want to ask something? Or you're satisfied with the information that you got?
Satisfied.
One more question, I think.
Do you share the performance test results with the customers? For example, from the last sample I could see that you measured the time, how much time is necessary to render. Do you share the best practices with the customers, how to make these scenes to keep the CPU free and not to take much resources? For example, not to render all scene but part of them, and do such recommendations. That's a bit different that we do here. This is actually meant so that if we have this kind of regression, we would never release that version, or we hope that we would never release that version. So there's not a lot of point in sharing that data, I think. But
I can answer.
Yes, I mean, if you go to, the data is there. If you go to our blog, we are pretty open and honest about what we do. If you go to, I guess it's blogs, Unity3D.com, Sakari has written 2 excellent blog posts about how we do this, and there's lots of data in there. But yes, I mean, the idea is that we want to catch these problems before they hit anyone else, all right? So, so yeah, I think general performance tips and tricks, I'm pretty sure some of our graphics guys and co-guys have written about that.
Yes, I can answer that.
All right.
So if you go on our website, there is a video section, and it contains all the talks that we have at all these Unite conferences that we keep every year. And on every Unite conference, we have a talk on performance tips and tricks and optimizations and things like this, because we know how important it is for our users to optimize their games and make them run really fast, at least on low-end mobile devices and all this. And a lot of users don't know some of these things, don't know where to look for it, don't know what occlusion culling is, don't know that they can like bake information and store it somewhere. They just do everything real time, live, and then the frame rate of the game drops really badly. So we have lots and lots of information available for our users on our website through these video recordings from the conference. And the presenters are actually Unity developers, so we give you like the inside view in all these things.
And then we have an excellent Learn team that also do
tutorials,
live training sessions online that you can attend. I think one of the recent ones was actually about the Unity test tools. They're free. You can sign up, and they're live, so you can ask your questions and get feedback directly from people that work in Unity. Yes.
And all of them are recorded, so you can watch all the sessions that you have missed.
Yeah. So you have this Learn section on our website, and you can go to live training, tutorials, and you can also search for videos from the conferences.
if the video is not here, you can always Google for it, or we can Google for you. Sometimes.
One question. You have many solo platforms. Do you have any problems with hardware, or you use cloud-based solutions while running your performance tests?
No, you should
we
use the
use
same
hardware.
hardware every time.
Yes.
Yeah, yes, we use same hardware.
So the whole idea with our performance tests is that we are fixing the hardware. So the only thing that is changing here is the Unity code. So what we would like to find and fix regressions in is the Unity code base. So that is what we are monitoring all the time. And that is the only varying parameter when we are running tests. So we fix the version of the operating system, we fix the hardware. The only thing that changes over time is the Unity code base.
And we also make sure that the hardware is isolated when it's running the tests. We don't use any virtual machines. We have dedicated machines only running these tests.
You can see you have the live training archive there too, so you can see all the previous live trainings that we have on our website.
Yes.
Start with fun with explosions.
And fun with lasers is also cool. Yeah, I think that we're done. It's 9 o'clock, and you can ask lots of questions and got lots of answers. And the official part is almost over, but we have some unofficial stuff going on after 10 o'clock or in half an hour. We'll go somewhere, drink some beer, and you can ask some questions that you maybe were afraid to ask with the broad audience. I don't guarantee any answers, but you can ask questions, that's for sure. Thank you for coming. Thank you for